Let's take a look at an example now where we're using the F-test of two variances. Ford Motors has two machines that produce a certain bolt. A quality assurance worker collected 42 samples from machine A and determined the standard deviation of the bolt is 0.1 centimeters. They collected 31 samples from machine B and determined the standard deviation of the bolt is 0.14 centimeters. At a significance level of alpha equals 0.05, can we conclude that the standard deviation of bolt is different between the two machines? So in this case, we are trying to compare things on the standard deviation. So we're trying to compare standard deviations here. So the null hypothesis in this case is, are these two standard deviations the same or not? So I will say that the standard deviation of A is equal to the standard deviation of B. Now the subscripts are very clear because we have machine A, machine B. So that's what we have for our null. And then our alternative hypothesis, we're wondering though, is it different between these? So in this case, we're wondering if sigma sub A does not equal sigma sub B. And again, remember these are all population parameters. The hypotheses are always statements about population parameters, not our sample statistics. So to choose the test, what we notice here is that we have two samples, and we are trying to compare standard deviations. Now, this is going to be good enough to tell us that we're going to use the F-test for two samples. So the two sample F-test is what we want. So if we go and turn on our calculator, we press stat, we go over to our tests, we can scroll down until we get to the option that says two sample F-test. So we click enter, and we have the option. Either we can enter in data. So if I gave you lists of data, you'd enter those into your list L1 and L2. But I instead gave you statistics. These are already calculated values. So my SX1, this is the standard deviation. Now notice in this case, I gave you the standard deviation. Here, this is going to be, say, S is equal to 0.1. And the next one we're going to have is that a sample standard deviation of 0.14. And these are really SA and SB. Now, if you had variances, so if the variance was equal to 0.1, what that means is that the standard deviation is the square root of 0.1. So you might need to take square roots to put things into the calculator if they give variances as opposed to standard deviations. So here I will put in 0.1. My number of the sample size of this is going to be 42. Down to the next one I have 0.14, and the number I have is 31. Now notice in both these cases that there is a difference in the standard deviations. We're wondering, is that due to random chance, or is that indeed there's something statistically different between the two? Our alternative hypothesis is not equal, so now we go down and we calculate this. Then we wait and we see that now it gives us some nice values here. So our test statistic in this case is F is equal to 0.51. Now remember, we said that because these are F tests, our test statistic is referring to F as opposed to T or Z. Our P value in this case is going to be 0.04549. And so we can make our conclusion by comparing this to alpha. Now, this is a note. This is one where the p-value is somewhat on the larger side. It's pretty close to 0.5, so we probably want to run more tests if we're trying to be statistically wise with our analysis. But at least for right now, we do have a small enough p-value to reject the null hypothesis. So since the p-value, which is equal to 0.04549, is less than 0.05, which is alpha, we reject the null hypothesis. So we reject the null hypothesis. We believe that there is a difference in the standard deviation of the two machines. And remember, we said that standard deviation gives us the how spread out or how much our results vary. So we don't want these bolts to be varying too much, right? Or they're not going to fit on whatever we're doing. So it makes sense that we'd want to know that there is a difference between these two standard deviations. And in particular, the one that's larger is obviously much more concerning because there's a lot more wiggle room taking place there. So there we go. That is the F-test of two variances.